In this video, we're going to be using formulas to find distance and midpoint. To find the distance between 2 points, let's say we're given a point x1 and y1 and x2 and y2, the distance is calculated by getting the square root of the difference of the two x points squared plus the difference of the two y points squared. We're going to use that formula in a moment, but before that we're going to also talk about to find the midpoint of 2 points. To find the midpoint of the 2 points, you need to find the average x value and the average y value. So you're adding the two x values together and dividing by 2, and adding the two y values together and dividing by 2. We'll do an example on that as well. First example, we're going to find the distance between 2 points. The question is, find the exact distance between each pair of points. Now, the key to this question, aside from the word distance, which we're going to be working with, is the word exact as well. So, first of all, we'll do part A. And whenever we're working with a formula, I always like to rewrite the formula just to help us remember. So we've got the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so for the distance, we're going to find, of course, the square root of, now I'm going to have this the x1 y1 value and the x2 y2 value. It's always important to label those before you get into it, everything. So our x2 is 1, so we're going to have 1 minus our x1, which is 0, all squared, plus 7 minus 2, all squared. So you can use your calculator to just ensure everything's correct, but of course we've got 1 minus 0, and that's 1, and of course 1 squared is 1. So we're going to have the square root of 1 plus, we have, I'll do this one in brackets just as it's written, 7 minus 2 all squared gives us 25, because 7 minus 2 is 5, 5 squared is 25. And we have our distance is equal to, the square root of 1 plus 25 is 26, and that is where we leave our answer. Because you'll find that the square root of 26 is 5 point something or other. We can't use that because we're just finding the exact distance. When you're finding the exact distance, unless you can write it as a whole number, or you can write it to the exact amount of decimal places, you have to leave it in the third form. So we'll leave it as square root of 26. Next, we've got part B. We'll do it again. It's just going to be a little bit more difficult. Once again, we're going to rewrite the formula. Distance is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Once again, this is x1, y1, x2, y2. You could have labelled it the other way around. It won't matter. This formula allows for either allocation, just as long as you identify your first and second point. Our x2 is 4 minus negative 3, which is going to be plus 3 squared, plus we've got y2 is negative 1 minus 8 all squared. Once again, we have 4 plus 3 all squared, which is 49. Because that's 7 squared, plus negative 1 minus 8 all squared, which is 81, because that's negative 9 squared. Under the square root, we've got 49 plus 81, or 9 plus 81 is 130. And does the square root of 130 equal anything? No, once again, it's an irrational number. It just has a lot of decimal places there, as you can see. So we'll just leave it as the distance is the square root of 130. If you can simplify the third, but at the moment, that's fine. We've just got the exact distance between those 2 points. Next, we're going to find the midpoint of a line segment joining 2 points. So to find the midpoint of the line segment that joins -3, -5, and 2, 8, first of all, we're going to label these. This is going to be our x1, y1, x2, y2. And we're going to use our midpoint formula that we mentioned here. So we've got m is equal to x1 plus x2 all over 2, and then y1 plus y2 all over 2. Now, this is a weird formula to use because you'll notice that there's a comma, and that's rare in formulas, but that's because this is the formula to find the x point, and this is the formula to find the y point. So for our midpoint, we're going to have our x1, which is -3, plus our x2, which is +2, all over 2. And then our y values, we're going to have -5 plus 8 all over 2. So if you want to, you can type this straight into the calculator. We're going to do -3 plus 2 all over 2, which gives us -0.5. So that's going to be -0.5. And we'll do it again for the other value. We're going to have -5 plus 8 all over 2, which is 3 over 2. Now, of course, we know that we can write these as decimals as long as you have the points. However, I like to write it in its exact form, which in this case is as fractions. So now we have a good idea of how to find the distance and to find midpoints. We're going to do another example, but this one's going to be a bit different. It's using a given distance to find coordinates. Okay, so the question is, find the values of a if the distance between 2a and 4, 9 is square root of 5. Now what's interesting about this is it said values, and we'll come to that in a second because there's more than one value that it could possibly be. So we'll use the formulas that we know to work this out. In this case, it's going to be the distance formula because it's using a given distance. So we're going to have distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And then when we put in our values, in this case we actually know our distance. The distance is the square root of 5. And the square root of 5 is equal to the square root of, now I'm going to label again, this is x1, y2, x1, y1, and this is x2, y2. So x2 is 4 minus x1 is 2, all squared, plus our y2 is 9 minus our y1, which is just a, all squared. So we'll evaluate what we can. We've got the square root of 5 is equal to 4 minus 2 is 2, all squared is going to be 4. So we've got the square root of 4 plus, now this is where things are going to get a bit weird. I'm just going to leave them as 9 minus a all squared because if I expand this, it might get a bit too messy. So I don't want to expand it just yet, just in case I don't have to. But what we have here, you can see there's a square root and a square root. So if we square everything, so I'm going to square everything that's going on here. So we're going to just get 5 is equal to 4 plus 9 minus a all squared. And of course, I can get rid of this 4 by subtracting 4 from both sides, doing the opposite of its sign. So if I take 4 away from both sides, I get 1 is equal to 9 minus a all squared. Now, of course, if I want to get rid of this square, I had to square root both sides. So I'll do that. I'll just get the square root of both sides. But when I square root 1, of course, as a numerical value, it equals 1, but it actually ends up being a positive and negative 1. Because, as you know, a positive 1 squared is 1, but a negative 1 squared is also 1. So when we're taking it from 1 and square rooting it, we don't know if we're going to be making it a positive 1 or a negative 1. And as that's the case, we have to assume it's both. So here we've got a positive and negative 1. On the other side, we just have our 9 minus a. Okay. just getting rid of that squared. If you were squaring this on its own, you would still have to do this. But when it's with a when it's in an equation, you only do it to one of the sides. So in this case, I've done it to the 1. So that brings us to a situation where we have now two equations. We have one where it's 1 is equal to 9 minus a, and negative 1 is equal to 9 minus a. Okay, so if we solve these, of course, I'm going to take 9 away from both sides. So we've got 1 take away 9 is going to be negative 8 is equal to negative a. And then they're both negative, so I can divide both sides by negative 1. By doing that, negative 8 divided by negative 1 just gives us 8, and negative a divided by negative 1 just gives us a. You could also recognize that negative 8 and negative a, that means that 8 is equal to a. So that's our situation here. On this side, we're going to do the exact same thing, but of course we're going to get a different answer because we're starting off with negative 1 on this side. If I take 9 away from both sides, I'm going to have negative 10 is equal to negative a. And similarly, I can divide by negative 1 or just recognize that they're both negatives and have 10 is equal to a. So find the values of a. There's of course two values. The values of a are 8, and a is also equal to 10. Okay, so hopefully that gives you a good idea of what possible questions you could be asked for both distance and midpoint questions.